Yeah, thank you very much. And one thing that we really are excited about right now with what China's been able to get into motion has been the fact that it's not just going back to the moon, it's not just going to Mars, which is the focus, but rather this question of what are the deeper mysteries that we can solve about the getting new information that we need to have in order to create better hypotheses into big mysteries like the origins of life, the nature of what governs the evolution of species. A whole bunch of big questions that you couldn't really properly scientifically grasp with the limited information we've been able to gather over the recent decades here on Earth alone. You sort of have to go outside of the sphere of the Earth's limitations in order to begin to properly address these bigger questions in a more responsible way than we've seen in a long time. And that's great. I mean, because ultimately, what we're going to be developing a little bit more in detail in this presentation is what is it that really brings us together as a species. We know what divides us. We've been researching or experiencing what divides us for a very long time, but what is it that really unites us in a proper way? Obviously, if you were an imperialist, you would say, well, a good way to unite the masses is fear. Keep them afraid. Keep them distracted. That unites them. There's other things that unite us that are a lot better and a lot more self-destructive to our own nature. One of the biggest questions that a lot of people tend to ask when you express some enthusiasm about going to space and about the space program is this very pessimistic but very common question of like, why bother going to space? We've been there already. You know, don't we have enough problems on the Earth as it is? It's validated a lot of, we have a lot of problems on the Earth. Why spend billions and billions of dollars on space travel when we are suffering famines and wars? We're suffering from tornadoes that kill people, and we're suffering from earthquakes that cause mass destruction and tsunamis, and we're suffering from all sorts of poverty. Poverty is a big issue. Most people in the world today don't have electricity. They don't have running water in toilets. That's a big issue. So why would we not better put our money into those things instead of things like space exploration? Well, okay, sure, the question exists, but it's, first of all, a totally false question. It's a red herring. And the reason why it's a red herring is because people aren't thinking about our problems and they're not thinking about the Earth, tornadoes, and all of these things from the proper context. They're not thinking about poverty and where it really comes from. Is it a material cause? It's certainly a material effect, but is it a material cause? When they think of the Earth, a lot of people tend to have this very common view. It's not, can't blame them. Right? Common view of the Earth. This is the wrong view of the Earth. Yeah, okay, it's spherical. That's fine. I'm not saying it's flat Earth. It's spherical, but it's not floating in this empty abyss of darkness. That's usually how people think of it. Is you got this Earth floating in emptiness. It's a very cold, dark place, kind of scary. If you take a better view of the Earth, it's a little bit, this is another picture, it's a little bit more truthful to reality, but it's still not quite the mark. Obviously, we're receiving a lot of energy from the sun, like Christine went through. We got a little image there of the plane of the Milky Way. But it still doesn't quite tell us really what's going on, because, I mean, ultimately, this is an artistic representation, but that's still utilizing the visible light spectrum. That tiny little sliver we saw in Christine's slide of the entire EM field, going from gamma rays all the way to radio waves. We're just seeing that little tiny bandwidth of visible light from red to purple that's being expressed here. A more truthful representation of it is, I think, captured in this NASA image, which gets at what is really happening in a more serious light. Because we don't just have planets being pulled and pushed by the forces of gravity. We don't just have light just being emitted from planets, and there's more going on. What we have are fields. What you have there is a dose of solar radiation, a coronal mass ejection. Obviously, the distances are much, much greater than what we see there, but the sun is constantly emitting bursts of radiation, coronal mass ejections, in this case, one just hammering the Earth. But it's not hammering the Earth directly because the Earth is protected by these fields of Van Allen belts. On the outside, you have electromagnetic fields as well, geomagnetic fields around the Earth that modulate, that mediate the incoming radiation, not only from the sun, but also from other galaxies, other stars within our own galaxy. All of these things, these supernovas, these quasars, these pulsars, they're constantly emitting radiations of all sorts. And I'm not talking about just radiation. You know, Christine went through the aspect of it that was electromagnetic, but we also have helium, alpha waves, beta waves that are fast, supercharged electrons being created, emitted by stars all over the place. Alpha waves, alpha radiation, you're dealing with positively charged helium nuclei that are streaming through interstellar space and being absorbed into our solar system and into the Earth. This is what Pascal, when he's doing work up in the Arctic teaching, he gets a very good view of aurora borealis, and that's really what he's watching is the intersection of the cosmic radiation with the geomagnetic field of the Earth, producing these beautiful dances of light. So what you have is this not empty space, but you have a really saturated, dense universe that's not empty anywhere, but that's an ocean of cosmic radiations of all bandwidths, constantly moving, pulsing, being mediated by electromagnetic fields of the sun, of every planet. Some planets don't have any. Luckily, the Earth has a big one, but this is what protects the life and the evolutionary processes on the Earth. And if you want to take an even more truthful perspective, we're just occupying one small little area of a Milky Way. That one, if you haven't guessed, is not our Milky Way. This is a, Patrick, which galaxy are we looking at? Andromeda. So this is actually a high-res image of Andromeda, a nearby galaxy that has a blue shift when we look at it, but has a similar configuration of a spiral nature that the Milky Way also has. So it's a useful artistic representation to just get people to think about how we only occupy one of the 4 or 5 arms that exist within the Milky Way. The Crab Nebula is maybe located about right here. You know, and that's, how many light years away is that, Christine, the Crab Nebula?
Right now, it's 750,000, or no, 650,000 light years for the light to have traversed.
That's huge.
I don't know the exact distance.
Okay. So you're dealing with immense, and they've only begun to calculate that there's something like 200 billion stars. Our sun just being one of these, you know, it's a very normal, nothing too special about that star versus other stars, but our star just being one of them. There's 200 billion of them, approximately, within the Milky Way. And recent calculations have approximated about 1.2 trillion known galaxies outside of our own galaxy system. It's huge, puts things into a really big perspective, right? So in the context of this immense idea, we have the Earth, and this is our environment. Whether people want to say that protect our environment. Okay, well, it's all nice to want to protect the environment, and we should be protecting the environment and paying respect to it. But at the same time, if we're thinking about it without the context of the fact that the environment on the Earth is part of a broader environment of a sun and a solar system and a galaxy, in a cluster of galaxies, then we have problems. And we're not going to be able to solve those problems in a responsible way either. And I'm just going to go through a few examples just to make this more visceral. This is, unfortunately, a bit of a lower res graph than I would have liked. But looking at a 500 million year chart, a geological chart of ice houses, of major ice ages, when the whole Earth becomes dominated by ice. This does happen periodically, right? We want crises to think about. This is a big one to think about. It may not happen in our lifetimes, but what is a causal driver of these ice ages? Anybody know? Cosmic radiation. You could read. All right, that was a test. Yeah, so cosmic radiation flows directly. What we see with the rate of the growth and decrease of ice ages is you have an increase and decrease of cosmic ray fluxes that are measurable within the ice cores and within broader geological samples of the Earth. We don't know how, but we know that there's a serious connection that we should be thinking about. And to take, that was 500 million years. Let's go into a little bit of a closer bandwidth here of 7,900 to 8,300 years ago. There's a small sampling here of a group of scientists working in Denmark under Heinrich Svensmark, who's a leading physicist and atmospheric scientist who's made some incredible discoveries about how cosmic rays shape climate change. And this is one of the studies he looked at is the rate of rainfall. And over this 4,000-year period, he was able to find, and there's many samples like this that he's taken, a direct correlation of cosmic ray intensity coming into the atmosphere, in the lower atmosphere, which facilitates and sparks a nucleation process of the particles in the atmosphere that allows for the attraction of all of the water molecules that rise up in humidity into the atmosphere, but they don't necessarily become clouds immediately. They require a catalyzer to help form into clouds that then can build up volume of water for rain to fall, right? So this is something which cosmic rays are, I mean, just looking at those relationships, that's not a coincidence. Cosmic rays are driving that. There's other studies that he's done, and there's a great documentary called The Cloud Mystery, which I could recommend everybody watch. Earthquakes. Recently it's been discovered that there is, I mean, earthquakes can kill a lot of people. Tsunamis kill a lot of people, it's related. Work has been done by a figure named Sergei Poulinets and a whole team of physicists in Russia and Italy around precursors. How do you forecast these things? And they found that the best precursors, the most reliable precursors that are available to us, exist by looking at the ionosphere, that place where you have that plasma of charged gas, where you have the cosmic rays intersecting with the Earth. This is where there are tons of electrons constantly moving around. And before an earthquake, this is the case of, this is Japan. I'm sorry that the resolution's a bit low. But over the course of several days before the major earthquake in 2011 that hit Japan and killed many people, there was an incredible condensation of electrons in the ionosphere that was completely anomalous. They'd never seen this before. Unfortunately, at the time, they didn't act on it and move people to proper ground, even though there were scientists saying, like, we should now do something about this and make proper precautions. It wasn't acted upon, and people died in the tens of thousands or more even. But again, if you want to be able to forecast earthquakes or look at what's causing them, we have to be able to look into space. We can't just look at the tectonic plates of the Earth alone. We have to take more into consideration. And then again, I'll just end with this one. There's a beautiful little series of graphs that was put together by a science-based, it's called the Scientific Basement Team in LaBrouche some years ago, which features two major cycles, the 60 million year cycle and the 140 million year cycle, that identifies several different variables, things that can be measured in the geological records, and how they're being mediated by the motion of the Earth around the center of there's a little image there of the Milky Way. The Earth and our solar system are constantly moving around that Milky Way on the upper right-hand corner in the course of, I think it's about 120 or 100 million year circuit to do one full rotation around the galactic center. In the course of that time, it's postulated that the solar system is moving through various arms. And as it moves through and outside of those arms, it's interacting with intergalactic cosmic radiation, either more or less. It's more in protection or more out of protection of the electromagnetic fields of our solar system, of the galaxy, which again has certain correlations to the collapses and increases of speciations of biodiversity. When you see great mass extinction, there's been 5 of them measurable so far. They're separated at certain intervals. We are able to measure certain relative increase and decreases of cosmic ray fluxes over 140 million years. We see the same thing over ice ages being moderated that we looked at earlier. Volcanism also has some interesting correlations. And others. There's much more in this, but this is what was put on this very, very nice graph. And this goes back about I believe this is 400 or so or 500 million years since the beginning of the Paleozoic. So everything is being moderated. All the problems that face life on Earth are being moderated by solar systemic and galactic causes. The current administrator of NASA, Jim Bridenstine, he made the point recently that dinosaurs didn't have a space program. They didn't have a NASA. So we do. We're the first species that's ever come into being that actually seems to be able to express a capability to not only discover these destructive processes, and in some cases creative processes, because it's not just that species have disappeared, but whole new sets of species have come into being, right? But we're the first species to be able to stop feasibly a destructive effect from happening that could annihilate the biosphere once more. How? We don't know, but certainly the fact that Jim Bridenstine gave this presentation while calling for an asteroid defense system is no coincidence. And that's something we don't have in place yet, but we should have had one for a long time. All of this brings in the question of what is the nature of the system? What is the nature of the species that contemplates the system? How does our idea of liberty and of freedom and of government, of law, how are these definitions affected by an appreciation of this higher idea of mankind and the universe, and how we can obey and discover its laws or not? These are all very important philosophical questions. There's for those of you who haven't seen our website, it's risingtidefoundation.net. A recent article we've posted on it is called The Coming Revolutions in Science, driven by the China and Russia Alliance. We cite here a Russian biochemist named Vladimir Vernadsky, who's the founder of the Ukrainian Academy of Science back in the 1930s, and a leader of Russian science, the father of the atom in many ways in Russia. He used to be much better understood, and the nature of science was much more in alignment with his thinking generations ago. It's less so today. One of the books he wrote was called The Biosphere. And he actually coined and popularized in the most scientific way the term biosphere that everyone uses. But it was Vernadsky the first to really define what this idea is as a not abstract concept that's measurable. And in this 1926 book, Vernadsky wrote, and he defined it in a very different way from what we're used to encountering, but I really like it. But based on everything we just saw, Vernadsky says the biosphere, which is the domain of life, may be regarded as a region of transformers that convert cosmic radiations into active energy in electrical, chemical, mechanical, thermal, and other forms. Radiations from all stars enter the biosphere, but we catch and perceive only an insignificant part of the total. The existence of radiation originating in the most distant regions of the cosmos cannot be doubted. Stars and nebulae are constantly emitting specific radiations, and everything suggests that the penetrating radiation discovered in the upper regions of the atmosphere by Hess originates beyond the limits of the solar system, perhaps in the Milky Way, in nebulae, or in stars. The importance of this will not be clear for some time, but this penetrating cosmic radiation determines the character and mechanism of the biosphere. And again, that's the image of the aurora borealis. And it's a beautiful idea, right? That constantly, we don't have empty space. We're constantly being bombarded, all of us right now, by trillions of nuclei, of neutrons from space, constantly moving through us, interacting with our bodies, not always in destructive ways, maybe sometimes yes. But this is constantly animating life. All of the photosynthetic activity on the Earth is being driven by plants, right, that have developed a chlorophyll molecule that absorb the light of the sun, that create and transform CO2 into oxygen that we use to sustain more life. It's a constantly, the sun is really driving the process of life, but it's not just like he says the sun, it's the entire spectrum of intergalactic cosmic radiation. And over long periods of time, as we saw with the previous map of mass extinctions, we have subtle but very important changes in the system of life as a whole, and which is constantly moving in a direction that has produced mammalian life, from lower forms of life that didn't have the ability to express more refined emotions. And out of mammalian life, we had a flow and a directionality towards producing higher quality beings that were able to then express higher forms of thought to the point that we could break free of our limitations of matter and start expressing thoughts that were of the divine, new discoveries of truthfulness, right? Of new laws of the universe that we could then translate into better life for human beings and for the biosphere as a whole. So this is really an incredible process of creative reason, which is embedded in the fabric of the universe. And a mechanism driving this thing is certainly cosmic radiation, and yet other forms of radiations we haven't discovered yet. So the last time, and the reason why we're able to measure all of these things is because we have a space program. Without the satellites, without all of the incredible technology that arose in the space program, we wouldn't be able to discover that any of these cycles really exist in the first place. And what does that unleash the space program? So what I want to do now is play a little video going back to the type of Vernadskian open system thinking, that we don't live in a closed system fighting for limited diminishing returns of resources, but that humanity is an open species, in an open system, able to constantly go outside of our limits to discover new resources when we're being creative, which somebody named John F. Kennedy once really firmly believed in as he organized society towards the impossible mission of putting a human being on another celestial body. So there's an inspiring little video. If you don't like to be inspired, I suggest coming back in about 4 minutes, and it'll be over.
We meet in an hour of change and challenge, in a decade of hope and fear, in an age of both knowledge and ignorance. The greater our knowledge increases, the greater our ignorance unfolds. No man can fully grasp how far and how fast we have come. But condense, if you will, the 50,000 years of man's recorded history in a time span of but a half a century. Stated in these terms, we know very little about the first 40 years, except at the end of them, advanced man had learned to use the skins of animals to cover them. Then about 10 years ago, under this standard, man emerged from his caves to construct other kinds of shelter. Only 5 years ago, man learned to write and use a cart with wheels. Christianity began less than 2 years ago. The printing press came this year. And then less than 2 months ago, during this whole 50-year span of human history, the steam engine provided a new source of power. Newton explored the meaning of gravity. Last month, electric lights and telephones and automobiles and airplanes became available. Only last week did we develop penicillin and television and nuclear power. This is a breathtaking pace, and such a pace cannot help but create new ills as it dispels old. So it is not surprising that some would have us stay where we are a little longer. Rest, but wait, if this capsule history of our progress teaches us anything, it is that man in his quest for knowledge and progress is determined and cannot be deterred. We shall send to the moon, 240,000 miles away, a giant rocket more than 300 feet tall, on an untried mission to an unknown celestial body, and then return it safely to Earth. But why, some say, the moon? Why choose this as our goal? And they may well ask, why climb the highest mountain? Why 35 years ago, fly the Atlantic? We choose to go to the moon. We choose to go to the moon. We choose to go but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that challenge is one that we're willing to accept, one we are unwilling to postpone. And therefore, as we set sail, we ask God's blessing on the most hazardous and dangerous and greatest adventure of which man has ever embarked.
So just as Christine was going through the relativity of time, right? That as you get out of the limitations of the Earth, you no longer have the liberty of perceiving the idea of time and space in a naive sense perception based way. Like obviously right now we're all separated in space, but are we separated in time? Kind of in some ways, because everybody who's perceiving me, whether it's Sean in the back or Christine in the front or Patrick behind her, are actually getting the wavelengths that are hitting me and you're receiving them in your eyes at different times. It's just so happening so fast that it doesn't really matter. But as soon as we start getting into space, we don't have the liberty of that type of assumption anymore. We have to take into consideration the fact that the sun the sun we see is 8 minutes away. It's 8 minutes in the past is what we're looking at, right? The light from the nearest star is happening 4 years ago. That's the light that we're seeing arrive from the nearest star to us. The light from the Crab Nebula is, as Christine said, in the tens of thousands of years distant. That's what we're seeing arriving from us. What it is technically now, and whatever that word means, is very different from what we can see. Similarly, if we're in another planetary system, in another star system looking at ours, with a big, big telescope, well, people in Alpha Centauri 4 light years away looking at the Earth are actually looking at the Earth as it happened 4 years ago. They're not looking at the Earth as it is today. Or people around the Crab Nebula are looking at the Earth 6,000 years ago, right? They're still looking at Troy being fought over by the forces of ancient Greece. So what JFK does as a poet, as a real statesman poet, is he's condensing our idea of space-time and all of the human experience to a period of, what was that? 50 years. 50 years. It's a great idea. So it puts everything into perspective, right? Such that the creation of, the discovery of electricity and its application was maybe days ago, minutes ago even. And that's really where this idea of, as Christine said in the beginning of her presentation again, the idea of the imagination, right? How is art and science connected? You have to be able to kindle thoughts that are not deductive. You can explain till you're blue in the face how interesting space is and how interesting human beings are. But if you're just describing and somebody fundamentally is pessimistic or has a pessimistic definition of a lot of these terms, they won't hear or receive any of the words you're using. They'll just be like, oh, that's your theory. That's a nice opinion that you have. We'll agree to disagree. And nobody really agreed with the idea of putting a man on the moon back when JFK was launching it in 1961. That was not a popular thing to do. He had to really expand, break the limits of people's imagination. So his power of poetry, which you can get in all of his speeches, is very, very important to do that. And today people miss it because they're looking at the past from the filter of their present experience, right? And so they say, one that I've heard a lot, you probably heard this too in the audience, is this idea that, well, the space race really wasn't about the love of truth or the love of mankind or any of these things. It was really about the Cold War. It was about beating the Russians, right? It was all about geopolitical battles. Yeah, okay, sure. That's why we put a man on the moon. That's why we organized. Everything was just to beat the Russians and say, nye, nye, nye. When you actually look at what JFK was trying to do, and it wasn't just him. There were many people around him, within NASA, within the broader space community, within the broader political community, within Russia as well. They recognized that the space program was not about that. And this is an excerpt from a speech 1 month before JFK was assassinated, where he called at the United Nations for a joint cooperation with Russia and the United States together to put a man on the moon as friends, to end the Cold War and that closed system idea of mutually assured destruction. And he wrote, or he said, I include among these possibilities for great power cooperation a joint expedition to the moon. Why should man's first flight to the moon be a matter of national competition? Why should the United States and the Soviet Union become involved in immense duplication of research, construction, and expenditure? Surely we should explore whether the scientists and astronauts of our two countries, indeed of all the world, cannot work together in the conquest of space, sending some day in this decade to the moon not the representatives of a single nation, but the representatives of all of our countries. And that's the proper spirit that would give birth to something like the moon program. It wouldn't be something as limiting as a geopolitical motive. Unfortunately, we know what happened. But in spite of his death, there was a continued momentum that was really tough to break. And leading up all the way until the late 60s, when after human beings had landed on the moon in 1969, we were making huge breakthroughs on nuclear physics. You had things that John F. Kennedy put into the budget. He begun in 1961 the NERVA nuclear rocket program with the, anyway. So the NERVA and what later became the Phoebus nuclear rockets were something which were proven, the actual rockets that weren't just using chemical propellant, but were using nuclear power, which was much, much greater than the power of propulsion of chemicals, and much smaller too, that would give us the ability to get human beings or equipment onto Mars in a matter of 3-4 months instead of the 9 months that it currently takes with chemical rockets. You had a program for fusion rockets. The blueprints were there. There was money being put into it in the 1960s to apply the power of fusion, which had at that point only been used for the hydrogen bomb for destructive purposes, towards propellant that would get human beings to Mars in a matter of 3 to 9 days, right? Which is very important, because if you're going to be able to start going into deep space exploration, you can't expect to put human beings outside of the protective field of the Van Allen belts into cosmic space for very long. We don't know what type of destruction that would do to our bodies. So the nuclear rockets were vital for deep space exploration. And even just getting the idea of the space-time more condensed between us, Mars, even things like Pluto, would be feasible to start sending equipment to all of the planetary bodies in the same way that planes shortened the idea of space-time from ship travel over the oceans, right? Where it took 40, 50 days to get from Europe to the New World. How much quicker did that trip occur with the invention of air travel? Hours, right? The original plan was to have a lunar colony, not just to plant a flag, play some golf, and never go again, as was the case. But the original plan was to actually have a permanent lunar colony by the 1970s. Wernher von Braun, who is the head of the NASA space program for much of this period, who was there with John F. Kennedy, had a program, a very advanced program for Mars colonization. Technically it's 1984 there, but he actually wanted it for 1982 as the first landing of a man or a woman on the moon, on Mars, and the creation of a permanent settlement. So everything was moving in a very, very different direction. And so what went wrong? Because it's true, we never went again. At a certain point in 1972, a decision was made to just stop the entire Apollo program. In spite of its success, it was just all canceled. The space shuttles were increasingly just retired. And to this very day, the United States has no ability to put a human being into orbit. It couldn't replicate putting a man on the moon if it wanted to right now, which is why there's a huge fight to revive this JFK program. But what you see here is an image of the NASA budget as a percentage of the US GDP. And where you would think, where it reaches almost 4.5%, you would think that was around the time that the space program was a success and we landed a man on the moon, right? But that was actually 3 years before the moon landing occurred. The budget had reached its peak as far as a percentage of GDP. By the time that the moon landing actually happened in 1969, it was less than 2.5%. It was slashed by half its peak funding. And you'd think with the moon landing, it would revive the spark of funding, of hope, the proof that it was a success, but it didn't happen. The funding just kept on getting cut year to year. to the point that in 1972, last moon landing, 2 years later, the Apollo programs are scrapped. And then we have we rarely ever see the budget going above 1%, to the point that today it's less than 0.5%, and that's the United States. And all of the projects at this point on are not goal-oriented. There's no real intention to accomplish direct objectives. They're all diffused mini programs that don't have a unifying program to them the way JFK had intended. So you're just demoralizing your astronauts, your scientists, and you're essentially waiting for this generation that had the living knowledge to die away. And today that's one of the biggest problems. The people who have the living experience of the space program are in their 80s and they're in their 90s. So that's a huge generation gap that has to be filled fast. Another way of looking at the collapse of this paradigm is expressed in this collapse of the manufacturing sector and the increase of finance, insurance, real estate, rental, and leasing. This goes from 1947, the end of the World War II, to 2009. It didn't change too positively since 2009. But what you see here is around the period of 1961-62 when JFK had come into office, or 65 actually. This is the period of JFK's administration where he levels off the collapse of manufacturing that had begun before him. And you have a spread of about 26% manufacturing in the economy to about 14 and a bit percent finance, insurance, real estate, things that are so-called, services. And as the space program is being cut, you have also the cut of the entire manufacturing base. The factories are being outsourced, shut down. And you have an increase of values that are not tied to real value. So the values of the businesses that are not producing are now being called the GDP. They're being called the source of value in the economy. And people begin to look more at the money than they are about the physical processes that are sustaining the life and the welfare of the nation. To the point that you have a crossover around 1981. This is a few years into the consumer society, the post-industrial model that was imposed onto us, where you have a crossover now, and the manufacturing continues to plummet with free trade, globalization, and services just continue to increase. The last graph I chose to look at here is something that affects the current bubble we're sitting on right now, which is the growth of over-the-counter derivatives, which are essentially fictitious speculative capital that's been permitted to grow into as a parasite onto the real economy, such that the real economy, which even that, it's questionable how much of the GDP is something that is tied to real values, but still, it's more real than speculative finance like derivatives. That is amounting to about $70 trillion in the US. The derivatives are about 10 times that, and that's a conservative estimate. These are things that governments in Europe and North America have been bailing out since 2008 when the bubble began to collapse. And they've been just sort of keeping the thing from collapsing by more injections of bailout, more austerity, plugging the holes, but no real breaking up of the banks, no real reorganization of the system as needs to happen if we're going to avoid the oncoming meltdown of the system. So that's a little example for those who haven't seen The Wolf of Wall Street, if you want to get a sense of the insanity of how our current system is wired. That's a really useful movie to get you into the mind of a Wall Street banker. And up until not that long ago, there really was no alternative being presented, except in 2013 when China really decided to take its developmental model and internationalize it. So the process of healing that China had begun after the Cultural Revolution, that process of investments into the real economy, uplifting of the educational qualities of your people, that took a period of decades. But at a certain point, there was a recognition that the Western banking system was ripe to melt down, and China and other countries around the world didn't want to go down with that system. And what's brilliant is they didn't just create the basis for a new alternative system, they created something that everybody can join, including Western countries that have been absorbed by the derivatives plague, by the consumer society plague. They created something that they said everybody is welcome to participate in. And this idea of a win-win open system philosophy is at the heart of the Belt and Road Initiative, the New Silk Road. And this is just a small example of just a few of the big projects that have united all of these different countries in Africa and Eurasia, even in Europe, around a way of thinking about money not as something just to be spent to buy things you want now, but as part of a developmental process of the long-term needs of your society, which your personal self-interest is tied to. These are high-speed rail grids in blue, high-speed and regular conventional rail being built up as a way of increasing interconnectivity, right, bridging the divides that separate us, and also creating impetuses for growing in new cities, new scientific corridors, new platforms of education that are giving people hope for the first time in a very long time. And it's not just about developing the Earth, because there's a space aspect to the new Silk Road. So there's a Silk Road in space, which China has become increasingly the world leader in space technology, with the Chang'e program first making one of its best breakthroughs in 2013 with its first landing on the moon in the top left there. And more recently, that's an image of the Chang'e 4 lander, which has landed on January 1st, 2019 on the far side of the moon, the first country in the world to do that, where it's understood that deposits of things like helium-3, that element that's so necessary for fusion, is located in greater abundance, which has been accumulating for billions of years on the surface of the moon, because the moon has no geomagnetic field to stop the helium-3 produced from the sun from embedding itself into the soil. So this is a part, and that's another image of the Heavenly Palace, which is under construction. That's an artistic rendering of what will be, and it's going to grow, which China has said to everybody is the foundation for their cooperation together. So we can do what John F. Kennedy was proposing we do back in 1963 by working together to not replicate all sorts of discoveries individually, but rather share them. And the idea of a lunar base is something now which, as we mentioned, the European Space Agency has signed into an agreement with Russia and the Chinese Space Agency to build a lunar base very shortly, by 2030 or so. We have things like like India increasingly getting on board. India has discovered, with their Chandrayaan 1 and 2 projects, they have discovered that there is abundance of water on the moon, especially on the poles, which is where China is going to be landing next at the end of 2019. We don't really know the nature of the water. It's speculated what we know that there's definitely hydrogen, there's definitely oxygen. There's good guesses that there might be actually water in some sort of an ice form under the surface, especially where there's a shadow in the craters where sun never hits. And that's something which is very exciting, because if we're going to be able to colonize the moon, you definitely need to have water, because you don't want to bring it from the surface of the Earth. It's way too expensive and energy intensive. But if it's there, that's a vital component of lunar industrialization, building rockets using hydrogen and oxygen for combustion, and a variety of other things that involve mining. India just launched a capsule which is going to land on the south pole of the moon in September of this year. It's already launched and it's on its way, called the Chandrayaan 2. The United States has also begun to get its act together. Under President Trump and Jim Bridenstine and a variety of other administrators, there is a recognition that the future is really space. And there is a huge fight within the United States for and against this orientation and this reawakening of JFK's program. The current video I'm going to show you was produced by NASA to demonstrate the new Artemis rocket program. And it says a little bit about what it is, what it intends to do, and what time frame we're looking at. Of course, the problem of funding is a big one, and that's something which there's no competent idea of how properly to fund it. Private sector companies should play a role, but the idea that you're going to put the governance of these new rockets and things into the hands of SpaceX or other private sector for-profit companies is not going to work out. It's never worked out properly in the past. So that's a problem. But the spirit is the right spirit. And the problems can work themselves out if people are honest. So this is a good little video. It's 3.5 minutes. I'm going to play this and maybe do another one before we shift gears and join Cuauhtemoc.
50 years ago, we pioneered a path to the moon. The trail we blazed cut through the fictions of science and showed us all what was possible.
Very pretty out here.
Today, our calling to explore is even greater. To go farther, we must be able to sustain missions of greater distance and duration. We must use the resources we find at our destinations. We must overcome radiation, isolation, gravity, and extreme environments like never before. These are the challenges we face to push the bounds of humanity. We're going to the moon to stay by 2024, and this is how.
This all starts with the ability to get larger, heavier payloads off-planet and beyond Earth's gravity.
For this, we designed an entirely new rocket.
The Space Launch System. SLS will be the most powerful rocket ever developed.
And with components in production
And more in testing?
This system is capable of being the catalyst for deep space missions
we need a capsule
that can support humans from launch
through deep space and return safely back to Earth.
For this, we've built Orion.
This is NASA's next-generation human space capsule.
Using data from lunar orbiters that continue to reveal the moon's hazards and resources.
We're currently developing an entirely new approach to landing and operating on the moon.
Using our commercial partners to deliver science instruments and robotics to the surface, we are paving the way for human missions in 2024.
Our charge is to go quickly and to stay, to press our collective efforts forward with a fervor that will see us return to the moon in a manner that is wholly different than 50 years ago.
We want lunar landers that are reusable.
that can land anywhere on the lunar surface.
The simplest way to do so is to give them a platform in orbit around the moon from which to transition.
An orbiting platform to host deep space experiments and be a waypoint for human capsules. We call this lunar outpost Gateway.
The beauty of the Gateway is that it can be moved between orbits.
It will balance between the Earth and Moon's gravity,
in a position that is ideal for launching even deeper space missions.
In 2009, we learned that the moon contains millions of tons of water ice.
This ice can be extracted and purified for water. It can be separated in oxygen for breathing or hydrogen for rocket fuel.
The moon is quite uniquely suited
to prepare us and propel us to Mars and beyond.
This is what we are building.
This is what we're training for.
This we can replicate throughout the solar system.
This is the next chapter of human space exploration.
Humans are the most fragile element of this entire endeavor, and yet we go for humanity. We go to the moon and on to Mars to seek knowledge and understanding and to share it with all. We go knowing our efforts will create opportunities that cannot be foreseen. We go because we are destined to explore and see it with our own eyes. We turn towards the moon now, not as a conclusion, but as preparation, as a checkpoint toward all that lies beyond. Our greatest adventures remain ahead of us. We are going.
We're going.
We are going.
We are going. We're going.
I really like that. And I mean, this is the thing. There's more crappy videos. I think there was something on the fraud of the moon landing. That's another big thing that's spread around the culture. Yeah, this Artemis program is, again, it's fragile, but it's the most serious thing we've seen in the past 50 years. With a really good timeline and website that NASA put together to educate people about the nature of this program, how it's different, what it intends to accomplish, and the fact that ultimately this is the foundation for international collaboration around a new system that ties value to the human mind and not to any limited resource that we choose to put a dollar value on and then fight over. The current timeline that they put on their website features commercial deliveries to the moon by 2019. Artemis 1, 2 are laid out there. By 2024, you're supposed to have the first human being, a man and a woman, landing on the moon, and the creation of a lunar colony. By the 2030s, the intention is to take that as a springboard with the lunar gateway that we saw of a space station orbiting the moon as a platform to Mars development, to extend the economy into an infinite spectrum, which Canada is playing a role in, where our robotics capabilities are being put to use on the lunar gateway construction, which again could still be sabotaged, but it's there right now, and it's something that not a lot of people fully appreciate, how we could tap into playing a positive role in something like this. The key is really getting over this ban of working with China, because since Obama was in office, there has been a legal ban on the West working with China on space technology based on very bad arguments. China's put its olive branches out, and other countries have encouraged us to do it. I think in general, Trump has indicated that he favors it, but there's a lot blocking him still that's preventing it from going forward. Nonetheless, the idea of lunar mining, developing fusion rockets, these are all at the tip of our fingertips. So this is what is defining the trajectory for the next decades and centuries of human life. Cuauhtémoc is going to take this. We've been looking at the macrocosm and going outside of the domain of human sense perception into the macro domain. Cuau is going to now take us into the micro domain, beyond sense perception into the very small, and the universe that opens up to our imaginations as well.